In the last video, we added a node at the end of the list by creating a pushtail function that used a call by address method. In other words, we took the address of this head and used it for this function. For today's video, I'm going to create another function that adds a node at the end of the list, but instead of using a call by address, we're going to return the address of the head node inside the function to the head of main. The first thing that I'm going to do is create a function prototype, and our data type will be a node pointer because we are going to return an address, and we're going to call this pushTail1. The parameters is going to be a node pointer, but instead of a double pointer, we're just going to use a single pointer, and then we're going to insert the data. So I'm going to go ahead and copy this and put it at the bottom and create a definition for it. On the right hand side, I went ahead and created a main, and what we have here is we have a node head pointer that is set to null. So when we call this function, since we're returning an address, we're going to have to say head equals pushTail1, and then inside we're going to insert head, and let's just say we're going to insert 45. We create an activation record for pushTail1, and inside pushTail1 we're going to have a head address. So let's do our node creation. As far as node creation, it is going to be identical to how we created the node in our last pushtail function. And so I just went ahead and copied and pasted. So we're going to create a new node on line 171. And then we're going to use the malloc function to allocate memory space in the heap to create our new node. Our new node pointer is going to hold the address of that newly allocated node in the heap. We currently do not have a linked list, and here we created a blueprint for a node. And so when we call our function here, we use lines 171 to 178. So in this case, 172 to 176 is just an error check if we do run into the case where there is a heap overflow. And in lines 177, we insert our data. In this case, we're going to insert 45. And then for 178, we're going to insert null to our next pointer values. And so now let's target our first case. What if our list is empty? And in this case, it is empty. And again, how do we know if our list is empty? We know it because head is null. If, and in this case, you won't need a star head since we only have a pointer. Here, all we'll need to use is just head because that is already a pointer. And if that's null, we want to set that to the new node. So head is going to equal new node, or we're going to assign new node to head, or head will be pointing to the new node. If the list is empty, which it is, our head will now be pointing to the new node. So this function will now then be popped off the stack frame, and then it will return back to main. And so now once I get to main, we officially have our first node, but we haven't returned anything yet. So this head in the main is not holding anything. When we return our head node, then this will hold the address of this first node. And so now we're going to create another function call. So we're going to say head equals pushtail. Even though we have it set here, we haven't officially returned it yet. But you'll see what I mean once we finish this. We enter the function again since we call it, and then we create a new node. And before this new node was created, an activation stack for pushtail1 was created. And then again, inside pushtail1, we have our head. We have our new node. When we return, once we complete this function and we return the address of head, this head will hold the address of this head, and it will be pointing to our first node. And once we call this function for a second time and we add 50, we go through 171 through 177, and in 177 we enter the data, which is 50, and then we set the next pointer to null. And so currently this is what our heap and our stack frame looks like. And then we go to lines 180, and the compiler will check this head equal null. Well, in this case, it doesn't equal null because head is pointing to our only node in the list, or our first node. So we have to create another condition. What if the list isn't empty? What we want to do is we want to do an else condition. Oh, but before I do this, I want to create another pointer. I want to create a current pointer. So this is going to be a node. We're going to assign head to that. And the reason why I want to create a current pointer is I want to keep head at the first node, and I want current to do the traversing. And so current is currently holding that address of 0x100. So this is 0x100 and 0x100. current is the pointer that I want to traverse while keeping head to the first node. Back to our function. What we're saying here is if our current next value doesn't equal null, then we're going to move on to the next node. So in this case, it does equal null. And so this condition in the while loop will become false, and the compiler will exit out of the while loop. And so once we exit out of the while loop, we want to assign currents next to our new node. In this line, currents next, which is this, we're going to assign that to the new node. And so now this next will now hold the address of 0x200. Head will still be holding the address 0x100. So now what we want to do is we want to exit this else condition, and then we want to return the address of head. And on line 195, once we return the address of head, this will now hold the address of 0x100, and this will now be pointing to our first node. After the execution of pushtail 1, our pushtail 1 activation record on the stack will be popped off, and this is what we have left. So now let's go through it one more time. Let's call another pushtail1 function. So we'll call it here. An activation record is created. We go through line 171 through 178 first because we have to create our node. We have our current node, and then we have our new node. And our new node is currently pointing to 0x300. Our head is pointing to this currently because we're passing head to it, so it's going to be pointing to the first node. And we're going to insert 50, well let's just say 55, and then this will equal null. Now we've executed lines 171 to 178. On lines 180 we create a current node and set that to head, and then the compiler will check 182 to 186. Is the list empty? No, it's not empty. The compiler will go to the else condition. And then while current next does not equal null, so it's going to check the current next. It's not equal null. It's 0x200. Our current will go to the next node. And so it goes to the while condition again. Is our current next equals null? Well, let's see. Our current next will equal null. And so in this case, it's going to exit this while condition. And current next will be assigned or will be pointing to new node. In other words, new node will be assigned to current.next. And so now 0x300, and then our current will be pointing to that. And then we're going to return the address of head. And what is the address of head? It's going to be 0x100. What this basically looks like is head is going to get assigned the address of 0x100. Let's compile and execute this. Let me go back to the main. So we're going to say head pushtail, and then inside pushtail we're going to do head, and then let's do 45, and let's execute and let's compile. And I have an error. Let me check what that is. Okay, and my error is I forgot to put 1 right here because we have 2 pushtail function. There you go. And now let's compile it. There's our creation of our first node, 45. Now let's enter 50. And a second node was added at the end of the node. And now let's enter 55. And there is our 45, 50, 55. And on the right hand side, that's the representation of our heap. Let's combine our functions, and let me add, there it is, and then let me do a push head. So let me copy these two and insert it here. So now we're inserting 20, so our output should be 20, 15, 45, 50, 55, and 5. 20, 15, 45, 50, 55, and 5. And that is our pushtail1 function that returns an address.